Let's start with the absolute basics. So, in this lesson, you're going to learn about digital audio and what that means and how we actually record and capture sound. So, it's worth noting that all sound is analog in the sense that it consists of vibrating waves. It's a physical process. If you studied physics at school, maybe you touched on this, but it's the same as light, the same way light is super high frequency waves. Sound is exactly the same physical medium. It's a wave, but it's much lower. Light, we're looking at megahertz, whereas with sound we're looking at hertz and kilohertz. Now, microphones capture those vibrating signals with a small diaphragm that actually vibrates, and it converts that into an electrical signal. And in the kind of analog days, that electrical signal then would have been captured to tape. But nowadays, that analog signal is converted into a digital signal. And this is done by an audio interface. So think of a USB audio interface where you plug a microphone in, you change the level, you adjust the gain, and then there'll be a USB cable going to your computer. And the audio interface will have an audio digital/digital audio converter inside. And this does the job of converting it from that electric analog signal into a digital signal of ones and zeros, binary, that a computer can read. And then on the way back out, it does the opposite. When you press play inside your DAW or on iTunes, it will convert that digital information into analog information to then send to the speakers and to the headphones. So once it's been converted to binary, the computer reads that information, saves it in the DAW or whatever recording software you're using, so that we can then edit it, process it, save it, share it, etc. So the computer reads that information and stores it in your DAW so that you can edit it, you can mix it, you can change it, you can write new stuff and add it to it. And then eventually when you're finished, you can save that information and share it online via SoundCloud or YouTube, or you can store it on your computer. You could burn it to a CD and share it with your friends. The limits are endless. Now, when you capture digital audio, it's stored in a slightly different way, because to convert that analog signal into ones and zeros, we have to decide how much of it we're going to convert, because we can't capture all of it. That would require too much information. So the sample rate and bit depth dictate the resolution at which the audio is stored. Think of it like a camera. If you have a camera with a really high resolution, it captures a really clear image. Of course, it's not actually capturing everything. It's not capturing real life. It's an impression of real life. But with a high resolution, you can barely tell the difference, because there's so many small pixels that to the human eye, it looks like real life. Whereas if you have a really bad camera where you can see the pixels and it looks all blurry, you can quite easily tell that, that's not real life. That's a poor quality photo. Well, audio's the same. When you're listening to high quality audio, it can sound almost real. But when you listen to really compressed, low quality audio, you can clearly hear the artifacts and the negative attributes of that poor quality. So sample rate and bit depth simply dictate the resolution at which the audio is stored. Now, let's look at each of those in a bit more depth, because it's really important that you have an understanding of these two terms if you want to understand how digital audio works. Bit depth, not to be confused with bit rate, is how many bits the computer uses to record the audio. And this is in terms of dynamic range. So if you imagine a waveform that's going like that, this is saying, well, how many layers of that waveform do we capture? And a higher bit depth means a larger dynamic range. So when we use low bit depth, like 16 or even lower 8, we're only capturing a small dynamic range. But when we use 24 bits, we're capturing much more range. So the noise floor that's always evident from recording, there's always a noise floor, is much lower. So to put it simply, a lower bit depth means more noise, and a higher bit depth means more dynamic range, which means the noise floor is further away from the audio. It's kind of hard to wrap your head around. I'll add a resource for further reading if you go to the resources section, but all you need to know is that lower bit depths like 16 and lower mean more noise, whereas higher bit depths like 24, which most interfaces now support, means less noise. Now, sample rate is slightly different, whereas bit depth is kind of the resolution at which we capture the amplitude and the steps. Sample rate's different. It's how many times we're taking a snapshot of the frequency. So it's how many times per second your computer takes that snapshot. And a higher sample rate means more frames. So this is more like a video than a photo. If you know how video works, it's simply lots of frames, lots of still images that are combined and they run really quickly so it looks like a moving image. And that's the frames. And frames per second, the most common of which is 25 for film, means that there's 25 still images for every second of moving video. Well, sample rate is the audio equivalent. So a high sample rate means there's lots of frames, it's capturing in terms of time lots of snapshots, and a lower sample rate means it's not capturing as many. High sample rates can also capture ultrasonic frequencies that we can't necessarily hear, but lots of people argue that it does have an impact on the quality of sound, and that's why some people really like listening to high sample rate music and mixing and mastering at high sample rates. Personally, I can't tell the difference, but a lot of people argue that high sample rate music, like 96 kilohertz, is better, it sounds better, it's subconscious, we can't hear these ultrasonic frequencies, but the theory is that they do still have an impact on the listening experience. But the biggest reason you would want to use a high sample rate is if you wanted to stretch out the audio. The same as with video, if you want to turn it into slow motion, you have to capture more frames. Well, with audio, same thing applies. If you want to slow it down, you need to capture more frames so that there aren't gaps between the frames. So if you're working with flex time and you want to be able to stretch out and elongate audio, then use a high sample rate, and at the final stage you'll bounce it down to a normal sample rate for listening. So that's it for basic audio and digital. Go check out that resource if you want to learn more about sample rate and bit depth.